All right, so we're into the last lesson. This is lesson 11.7. This deals with being able to switch ratios. So we've talked about area ratios, and there's an easy way of showing this. Most of this is written, and it's understanding verbally what they're trying to tell you. Then you have what we call volume ratios. And then, of course, there are the ratios that we've talked about that we have that are all the same. They have different names, but they're the same. So you have perimeter ratio. You have similarity ratio. And you have scale factor. Now, these things are all very similar, if not the same. The only real true difference is with scale factor, you have to be careful of which way you write the numbers. Remember, if your shape is getting bigger, the bigger number goes on top, and if the shape is getting smaller, then the smaller number go on top. But perimeter and similarity ratios are where you compare the two different shapes. All right, so you are able to go from area ratio to perimeter ratio, and you're able to go from volume ratio to perimeter ratio. Now remember, these names are synonymous. Okay, but what you can't do is go from area ratio to volume. In order for you to get there, you have to go to perimeter and then go to volume. Or if they give you a volume ratio, you have to go from volume ratio to perimeter and then to area. It's kind of like in a right triangle where you're trying to find special right triangles, and you have to go from the hypotenuse to the short leg, and then from the short leg to the long leg. You can't go across. Okay, it's the same concept, except here you just have to know your opposites. So hopefully you know area ratio is always in units that are squared, and then if I needed to go backwards, I would square root. And then of course volume ratio are always in units that are cubed, and if you're going to go backwards, you cube root. So it's being able to move forwards and backwards. What ratio do they give me? And how do I change my numbers to get to the ratio I need? Forwards, backwards. Okay, so if they give me two areas, I make an area ratio, and I must always remember to do what first? Always reduce your fractions. Okay, you always reduce your fractions or ratios before you start. Once you reduce them, then you do the math to change them. So if they give you an area, two different areas, you find the area ratios, then you turn around, you reduce that, and then you change it to perimeter by square rooting, or you reverse it, and you write the perimeter ratios, you reduce those, and then you square them to get area. All right, so we'll do a couple sample problems. Shouldn't take much, and then the notes for today are relatively quick, okay? Because it all revolves around this concept. So if you're looking at this while you're doing your work, you won't have much of a hard time. The problem is remembering how this works. So let's look at one of the sample problems that they give. There's they talk about let's see, what do I want to do? We'll work on the first got it number 1, okay, which is on 774. And it says the two cylinders are similar. If so, what is the scale factor of the first figure to the second figure? So we're looking at them to see if they are similar. Okay, and if they are similar, then that means their scale factor and their area ratios would be related to each other. So let's see, if we do the scale factor, that would be from the first figure it's getting smaller, so it would be the scale factor of 5 to 6. Okay. So if they are similar, the scale factor is 5 to 6 because first figure to the second figure means your figure is getting smaller, so my scale factor has to have the smaller number on top. Okay. Now you have to be careful because in the book the answers are wrong. They do it backwards for some reason, and it's not correct. All right. So here's our scale factor, and if I wanted a ratio, I would check the next one, okay, and it's 10 to 12. So I take the two different measurements and I see, does that 5 to 6, and this of course reduces to 5 to 6. So yes, those two shapes are similar, and that is their scale factor. If they wanted to go from the smaller shape to the bigger shape, I would just flip those ratios. All right, now here we go. If I needed an area ratio, what would I do with these to begin with? I would square them. So my area ratio would be 25 to 36. And then, of course, if I wanted a volume ratio, I have to start with the perimeter, and I cube it. So this would be 125 to, and of course, you have to remember how we're using our calculator. It would be 6 cubed, that's 216. So notice you reduce the fraction first, and if you wanted to, you could actually put in the ratio as a fraction, right? So you could go 5 over 6, and then you could raise the whole thing to the cube, and it would do it for you, right? And it gives you the answer. So it's really important to learn how to use your calculator. If they give you the volume ratio, you would cube root, and I showed you how to cube root on the last video, and it would give you your perimeter, and then you would square it to get your area. Okay? Remember, everything revolves around the perimeter ratio. So you can never go from volume to area. You got to go from volume to perimeter and then to area. But all of these are just manipulations of whatever ratios you're looking for. All right? So I'm going to look at got it number 2. You go ahead and try it, and then I will do it for you. All right, welcome back. They gave you the two similar figures, and they said the area ratio was 144 to, they gave you two areas. Now, how do I know the areas? Because they're units squared. So the first thing I do is I check to see if they're able to be reduced. So that's 144 over 324, okay? I hit enter. Okay, so in actuality, the area ratio is 4/9. And I need, if I needed to change that to a volume ratio, I wouldn't be able to go from the area ratio. See, this is the area ratio. So I need a perimeter ratio. So what do I do with those? Correct, I would square root them. So I would do the square root of 4/9. And, right, the perimeter ratio would be 2/3. Then to go from this to volume, I would cube it. So then it would be 2/3 cubed is 8/27. So this would be the area ratio reduced. I square root it, I get the perimeter. I cube the perimeter to get the thing. So area to perimeter, perimeter to volume. Sometimes they give me volume to perimeter, cube rooting, and then squaring. Okay? All right. Other than that, good luck. Do the best you can. And that's the basics. Just making sure that you keep track of the vocabulary and what you're given. If you're given area, you square root it. If you're given volume, you cube root it. And then you either square root it or you keep it here, depending on what they're looking for. Okay? Nice little tree. All right. Last but not least, I am going to add to this, and I apologize. Hopefully you haven't gone away. You also need to be able to find areas of similar shapes using the area ratio, but they may give you the volumes. So that means you have to change the ratio, then you're going to do some cross multiplying and solving. So I'm going to do one of those types of problems so you understand what we're talking about. Okay? So that would be the got it number 3. Okay, so you have volumes of two similar solids, and they give you the volumes of 128 over 250. So I write 128 over 250, and then I have to make sure that I reduce it, because this is a volume ratio. And I need an area ratio because I'm trying to find an area. Okay? They give me the area of a larger figure, but I need an area ratio, so I've got to change this to a perimeter ratio. Okay, so here we go. Here's my calculator. I put it in as a fraction, 128 over 250, and I make sure I reduce it. It's 64 over 125. This is still the volume ratio. Okay, then I know I have to change that, so I cube root it. Okay, so I cube root okay, and that gives me a perimeter ratio of 4/5. Problem is that I still need the area ratio, so what do I have to do to this? I went from volume, cube root it, now I've got to take that and square it, so that gives me an area ratio of 16 over 25, because I square it, equals, and then they give me the area, the surface area, of which shape? The larger one, which is 250. And I need the area of the smaller one, x. Now I do my cross multiplying and solving. So getting to the correct ratio, then setting up a proportion, and cross multiplying and solving is really, really important. Okay, so now I do the cross multiplication. You know that 16 times 250 is 4,000 divided by 25 is 160. So x would be 160 meters squared. All right? Okie dokie. Now I wish you well. Good luck.